Today we are going to talk about search augmented information filtering distillations presented by Team 18. So the problem statement is that large language model is still facing knowledge obsolescence problem. When you ask large language model what's the specific event of February 2025, they're going to say, okay, my training cutoff date is somewhere in January 2022, so I cannot answer you. To fix this, we can use search augmented models such as Cell7B that can utilize searches over web for the latest answer. So what is self-SMD? Self-SMD is basically a large language model that can tell you, okay, if the information is distracting or not, and they're going to produce the final results based on if it's distracting or informative. The problems we're going to solve is first knowledge obsolescence. The second entailment model for self-SMD is right now a couple hundred minutes. It is not state of the art, so we want to improve on that. And third, the computation cost for self-SMD is very resource intensive and is high. We want to lower it down. The significance of the problem is that it first has real world impact. The fact-checking, question answering, and everything rely on up-to-date information. Second, the scalability. Deploying some lightweight models for filters, search filtering enables broader applications. And the related work, we have seen that from large language model to small language model distillations, supervised fine-tuning can actually move the complex reasoning abilities from the bigger model to a smaller model. So we are going to do that. Some novel contributions of our solutions first includes the distillations for efficiency. No one has done this before, and also upgrading entailment mechanism. First, we're thinking about replacing Cell7B to DBERTA, and also we're going to implement larger entailment model that has chain of thought reasoning. Next, moving on to task.
So for the project overview, we extend the Cell7B paper by testing different entailment models for search filtering, fine-tuning Cell7B on new datasets, and distilling smaller models with strong performance. Next slide, please. For the training data, we use approximately 52K Alpaca GPT-4 samples, each augmented with search results. Entailment labels are added using DBERTA or Mistral 7B, and the data is converted into cell-style dialog format. Next slide, please. For the evaluation data, we evaluate on climate fever and hate speech detection. These datasets measure factual accuracy and fairness in real-world scenarios. Next, let's move on to methods.
Yeah. So this is an overview of our model architecture. So we have the original search results, which for our method, we then use DBERTA and Mistral 7B as our two new entailment models to create two separate data sets. These data sets are used to fine-tune Cell7B, and then we evaluate them on the climate fever as well as the hate speech detection data sets. Next slide, please. So the training data set is created by using the original Alpaca search results. Then DBERTA and Mistral are used to classify each search result into whether it's informative or distracting. And this gives us in JSON format our training data for fine-tuning. Next slide, please. So fine-tuning, we use conversation style Dolly V2 and as a way to convert our sale training data. And then we take our model and then add loader weights after freezing the initial model, and then we fine tune it. And these are some of the parameters that we use for that. Next slide, please. For the second task, we do knowledge distillation. We distill our model into two models. One of them is a 500 million parameter model after Quen, and the second is a 1.5 billion parameter model. And these are the details of that. Next slide, please.
So for the results, first we have the results on the climate fever dataset, and we see that Mistral 7B dataset, which was used to create the labels, performs better as compared to the DBERTA generated labels. And next slide, please. And for the, we have the distilled model results over here. And over here, we have the two distillation distilled models, which is Quen 0.5b and Quen 1.5b. We see that it has similar performance as compared to the original entailment classification model. And then in table 2, what we do is we combine these distilled models with a generic Quen 3b instruct model, which is not specialized like Sale 7b, and yet we're able to get similar performance to Sale 7b, suggesting that we can incorporate these in low-level devices which are resource constrained. This is our main analysis for the distilled part, and for the fine-tune part, we can see that fine-tuning a model which has both causal reasoning abilities as well as causal reasonabilities as well as lead to better performance, and Mistral 7B clearly outperforms DBERTA. That's the end of our presentation. We answered both of our research questions, and we'd be happy to take any questions. Thank you.